Hi, my name is Siti Nurina binti Isa. We are from DTM 5B Group 7. Today we're going to present to you our title, which is Production of Tenderizing Solution Utilizing Unripe Papaya, Pineapple and Onion and its effect on meat tenderness. Background of the study is papaya, which is carica papain, and mountain papain contain the cysteine protease enzyme known as papain, commonly referred to as papaya proteinase 1. In the food industry, papain is used as an active ingredient in many commercial meat tenderizers. After that, for onion, proteolytic enzyme, which break down protein, are found in onions. This has the ability to tenderize meat, but only when the onion is in direct contact with the meat. A protease is an enzyme that catalyzes, which is increased reaction rate or speeds up proteolysis, breaking down protein into smaller polypeptide or single amino acid and promoting the formation of new protein products. Next, bromelain, along with the papain, is one of the most widely used proteins for meat tenderization. Bromelain is offered for sale as powder that can be sprinkled directly on raw meat or mixed with a marinade. So the last one is meat texture is used to describe meat tenderness. Although this term also describes the firmness or coarseness of a meat surface. Tenderness is an important and characteristic trait of meat quality and includes instrumental measures and consumer and trained pain sensor assessment, which determines satisfaction, repeat purchase, and willingness to pay premium prices. Objective is to produce a tenderizing solution, and the second one is to measure the effect of tenderizing solution in meat, and the last one is to select the best formulation of a tenderizing solution. As for the research scope, the researchers want to determine if they can measure the effect of tenderizing solution on meat. Through analysis, the effect of the tenderizing solution on meat can be determined. After that, the research on the meat tenderizer content as well as the analysis were conducted using papain, bromelain and onion extract. Although synthetic papain, bromelain and onion extract are frequently used in the manufacturing of food, there is a growing interest in natural solutions due to concerns regarding safety. Problem statement that was found in this study is this meat tenderizer is in the market in powder form. Even by searching in online stores, there is no tenderizing solution. Instead, they use this powder form. So we propose using a solution that can tenderize the meat due to low cost, accessible to the raw material, and still can tenderize the meat. And the last one, this meat tenderizer powder has no halal certification and the halal is doubtful. So we propose using our meat tenderizer solution using a plant-based ingredient, not using animal-based ingredient, and there's no chemical in the solution. Significance of study is we can produce plant-based meat tenderizer solution so that halal is not doubtful. And also, it is effective tenderizing instead using of the powder form meat tenderizer.
Hi, my name is Muhammed Suhaili bin Ronnie and I will present the literature review. Papaya. The proteolytic enzyme papain, which is a member of the papain superfamily, is essential for several key biological processes in all living things. Sugi et al. 2018. Pineapple. The term bromelain refers to a group of proteolytic enzymes or proteases, natural proteolytic enzymatic complex that are present in the tissues of pineapple stems, fruit and leaves. Apple Biochem Biotech 2019. Onion. Onions have proteolytic enzymes which make them excellent for softening meat. Additionally, onions are the most popular veggies that are very low in calories. Wiki 2021. Meat tenderizer. Meat tenderizer refers to a powdered naturally derived enzyme powder. The enzyme most commonly used is papain, which comes from papayas, or bromelain, which comes from pineapple. Juan 2019. Protease. A protease is an enzyme that promotes the production of new protein products by protease. A protease is an enzyme that promotes the production of new protein products by catalyzing the breakdown of proteins into smaller polypeptides or single amino acids. Judith S. 2019. Texture analyzer. The texture analyzer can be used to analyze the texture of a meat for finding its tenderness. This equipment can make it easier to identify the exact value for meat tenderness. Ernst E. 2018. Next is our methodology. The first methodology is overall scope of project. First, we make a preliminary study to know the combination and proportion of factors. Next, we analyze the meat texture before soaking, after soaking, and after cooking. Then, we design the number of experiments using DOE software by measuring 3 responses. And next, we analyze all of the response using DOE software. Lastly, we compare all of the best formulation with commercial tenderizer. And then we have our solution preparation. First, we start by selecting the good condition of unripe papaya, onion, and pineapple. Then we cut them into smaller pieces. Next, we blend all of them in a food processor. After that, we sieve all of the blended fruit to get their juices. And then we mix all of them into a solution. And lastly, we have the process for our meat tenderizer. First, we start by cutting the meat into 3 by 3 cm. And then we record the meat texture before soaking. After that, we soak the meat in our solution for 2 hours. After 2 hours, we then check the texture for our meat after soaking. And after we get the result for after soaking, we then cook the meat by using frying method for 5 minutes. After that, we record the meat texture again by using CT3 texture analyzer to gain the result. And that is the end of our methodology.
My name is Visalini Rathina Kumar. My metric number 33DTM20F1018. Today I would like to present about result and discussion. Based on the research finding, we have the 4 stage: preliminary research, optimization, formulation, significant determinant on the response cooked meat, and a comparison of improved the tenderizer solution formulation with the commercial tenderizer powder. The preliminary study was conducted as we identified the range of solution. The table showed that preliminary study of the difference in the tenderness was higher for solution 5, with the greatest variation in hardness between before and after soaking. Solution 5 was 64.6 gram. The graph showed that the preliminary study of the difference in tenderness was higher for solution 5, which is the first solution unripe papaya 30 ml, second solution unripe papaya 15 ml and pineapple 15 ml. The third solution was unripe papaya 15 ml and onion 15 ml. The fourth solution pineapple 15 ml and onion 15 ml. And the last solution unripe papaya, pineapple and onion 10 ml. After soaking or before cooking, and the combination of the 5 solution proved to reduce the reading of meat tenderness. The result of optimization solution was considering the determination that the best combination is papain, bromelain and onion extract. The next step is to establish the ideal ratio of the combination. Table 2 show the generate and receive ratio. Then using the 15 solution provided, we repeat the previous process minimum and maximum, only modifying the ratio. We can conclude the best ratio for the combination of papain, bromelain and onion extract is 1:1:1. Then the input each of the 15 result into the DOE software to determine whether they are accurate. We also indicate the best possible combination of 15 ml onion extract, 5 ml papain, 5 ml bromelain. Disability in combination, although 83% of the data was accurate. We solidly proved it by conducting the experiment comparing our tenderizing solution approach to the commercial powder. From the Pareto chart, A was papain, B was bromelain and C was onion. The most significant difference between the first and second is bromelain, followed by the onion. From the model value 0.030 is the less than p-value, which is significant. The p-value for the papain, bromelain and onion models are 0.021, 0.010 and 0.062, they respectively, indicating a significant difference between the values. R square of 91%, which is more than 85%, show the reliability of the result. Comparison optimized tenderizing solution formulation with the commercial tenderizer powder. Our best solution from the table was unripe papaya 5 ml, pineapple 5 ml and onion 15 ml. To mix 25 ml tenderizing solution, we use 1 tablespoon commercial tenderizer powder. 2 hours of soaking, receive a projection of the outcome. Following the suggest combination will allow us to determine whether or not our results are accurate. While we were adhering to the suggest ratio, we made the decision to the contracts with the meat tenderizer on the market, the hardness 1 and hardness 2, discovered that commercial meat tenderizer have a poor outcome when used to cook meat using the frying method. The texture was also hard.
Conclusion: combining pineapple, unripe papaya and onion could be an effective tenderizer for the meat as an actual preservative without impeding the natural quality of freshness. This solution could effectively improve the tenderizing of tough muscle in meat without disturbing quality parameters, significantly contributing to the agricultural processing industry. So, the best formulation of this solution was determined by mixing 5 ml of pineapple, 5 ml of unripe papaya and 15 ml of onion.